welcome. In this lecture, I want to go through a lemma, and I'm actually going to go through the proof. I believe this is the first time we're doing this in this course. It's going to be useful, and I have been avoiding doing a lot of the proofs because they tend to be longer, and I know that can be overwhelming in videos, and so I'm waiting to do those in person. But this one, I feel like it's a length that we might actually kind of be able to do it, and it's good to actually finally see some proofs on the material that we're covering. So let's go ahead and do this. So we're going to start out, well, first with the statement of the lemma. So lemma. And obviously this is the circumstance we're looking at, but we first want to kind of start with our suppositions. We suppose that a and b are integers. Okay. And now, you know, and it was good to kind of write this in a sentence like that, because then it's an if-then statement. So we're going to have that if A divides B and B divides A, then B is going to equal plus or minus A. Okay. So let's kind of go through the scratch for the proof. Well, I guess I've been doing scratch in general in orange. So let's do that to kind of be consistent with how I've been doing things. This is kind of symbolically, and then I'll write it in complete sentences. But this is how one might, it's going to look a little different than the scratch trick I've been doing. A lot of times this is actually how people will write things on a board, just to give you an idea of kind of how it goes without kind of giving you full paragraphs on the board. Some people like full paragraphs on the board. I actually usually didn't. Okay, so here we go. So we'll start with, we're going to consider kind of two different circumstances first. So we're going to look at the situation when A equals 0, okay? So this is scratch, so I'm not necessarily telling you everything I'm going to look at. So let's consider the circumstance of A equals 0. Okay, so what happens in this circumstance? Well, we know, right, so this is going to be since A divides B, right? That's in our if part of our statement, so we can, assume that that's true. So since A divides B, I'm going to know that 0 divides B, because A equals 0. This is the same thing as that. Okay, great. And then and you may not remember, you might have to check back from the previous one, right? I was talking about D3. But then that's going to tell me that, right, that can only happen if B equals 0. And then, since I know that A equals 0, then I'm good, right? I have that A equals B. They're both 0, so A equals B. Great. I can call scratch proof / Blackboard sketch. This is, something that professors do. We sketch arguments on the board. It gets even worse if you're going to a research talk. People don't include all the details. Okay, now let's look at the circumstance. So another thing that can happen is when B equals 0. And a lot of times you're going to want to cover these kind of, so students ask me, when do you separate, deal with a different circumstance separately? And the way that I usually tell them is that the argument that you come up with, you should check that it works in all circumstances. And if it doesn't, then you're going to need to handle those separately, okay? So, and sometimes it will be when something is 0. So you should check that. You're like, does my argument actually work if the thing is 0? Okay. So let's kind of look at this one. And then this is a circumstance. We're going to do something that this turns into every student's favorite thing to say, whether or not in this particular circumstance it works. But I'm going to explain to you when you can use it. So I'm going to say by symmetry. Okay, so when can you use by symmetry? It does save you time, so it's good to know. When can you use by symmetry? My explanation of it is if I could get this argument by just changing the names of everything in the other argument, I can say by symmetry. Okay, so in this case, I could change, if I swapped A and B in the first argument, I would get the argument for the second, right? So this is a symmetric circumstance, right? Because I have both of these. And so B equals 0, just swapping the variables is going to be the exact same argument works. Okay, so that's why we can use symmetry here, which is a very useful thing to be able to have. Okay, now that we've dealt with these, so we can assume that they're, neither of them is 0. So we can assume that A does not equal 0 and B does not equal 0. Okay, because we've already handled those circumstances. Now here we go. So the fact that A divides B, right? This is just in our the if part, so we can use that. So the fact that A divides B. Well, this is, like I said, a lot of times you're just going to take these things and like say what they mean in terms of the definition, and that gives you something to work with. Okay, so this is going to tell me that there exists and M1 contained in the integers, so that, right, this is just the definition of A divides B. So maybe I'll even write this. So this is just by the definition of means divide, such that, and then I have B equals A M1, right? But then I can kind of like go the other way around. So the fact that B divides A is going to tell me that there exists, again, by the definition, and M2 in the integers, so that, and now I can just, so A equals B M2. Okay, so now I know that I have both of these. And now I can kind of combine them to get, what is my aim? I want that B equals plus or minus A. Just keep that in your mind. This is what we're aiming at. And we can kind of see inside of here, and I'm going to check for a moment which one we're going to replace with which, right? So you can see that I'm going to want to replace the B in here. So I have a B here, I have a B here, and then I'm going to be able to stick that in here, right? Okay, so this is going to give me that. So these two together are going to imply that, right, the fact that I have this here is going to imply, well, now I have that, so A equals B M2 is going to tell me that A equals, and then I can put in this A M1 here, so I have A M1 M2, okay? i.e., right, the parentheses don't matter here, so i.e., right, so this is A equals A times M1 M2, right? Okay, well, the fact that A equals A times M1 M2, what does this here tell me? So now I have that this has to be 1. Okay, so now I know that M2 M1 or M1 M2 has to equal 1. So, from this part right here, right, that this is going to have to equal 1. So my M1, M2 has got to equal 1. Okay. So now I know what are the possibilities. I've got two integers that are multiplying to 1. Okay, so there's either, so I have two possibilities. So I have either I have that M1, let's just kind of turn these to kind of be blue. So I either have M1 equals 1 and M2 equals 1. Okay, well, what happens in this possibility? Then I know that, so this one's going to tell me that B, right, this B here, which was equal to So what was this B here equal to? So this was equal to AM1. So this is going to equal, and so I've still got the A there, and then my M1, right? But my M1 equals 1, so this is going to equal, bum, bum, bum. Now I have that it just equals A. i.e. B equals A. Haha, victory. That is one of the possibilities that I'm aiming at. So now let's look in the other circumstance. So what else can happen here? So now we can say that they're both equal to -1. So M1 equals -1 and M2 equals -1. Okay, now, so this is going to give me, well, I can just put in, I can do the same thing again. So now I have B equals, and then I have A, and then I'm going to put in this M1. So this M1, which is going to equal, and then again, this is -1. So now I'm going to get minus A. We'll just kind of do it like this, because this is coming from this, right? This is -1, and here this was 1. So this is going to give me A. Oh, nice. So now I have B equals minus A, which was the other circumstance. Okay, so in all circumstances, I have exactly what I need. Amazing. I'm done. Okay, so I'll explain what we did so far, and then I'm going to try to do this actually in 2 videos. I'm going to do the best I can at not making this be too long in one video. So what did we do? We covered the circumstances of A or B equaling 0 first, so that we can not have to worry about them later. And so I'm going to have that, right, because where did we run into trouble otherwise? We run into trouble exactly here, where I said, oh, the fact that A equals A times N1, M2 tells me that M1, M2 is equal to 1, right? But if A was 0, then that's not going to work. Okay, and the similar kind of thing is going to happen with B. So we just covered those circumstances first, a little separately. So the fact that A equals 0, and since we know that A divides B, so that's what's coming into play here. So this is A divides B. A divides B, then that's going to tell me that 0 divides B, which is going to tell me that B has to equal 0 by one of the properties we went through before, which is going to tell me then that A has to equal B. And that is, so we're done. Okay. Now, the other one we can do by symmetry. What does symmetry mean? It means that I can just do the exact same swap of variables everywhere, and I would get exactly the argument I need. And so we can do B equals 0 by symmetry. It only really works because even our assumptions here are symmetric, right? Okay. So now we can assume that both of them are non-zero. So we have, and we have things to work with. We have A divides B and we have B divides A, and then we're going to use those definitions of them. So it's good to have, I always say this, one of the first things you often do is unravel definitions. So A divides B tells me that there's going to exist an integer, M1, such that B equals A times M1. This gives me a separate integer, so that A equals B times M2. Now I can stick this B into here, so I'm going to get that A is good. The fact that A equals B times M2 is going to give me that A equals, and this is where I stick this in to here, and I get A M1 times M2, i.e. A equals A times whatever this integer is. That integer has to be 1. How can I multiply 2 integers and get 1? Either they're both 1 or they're both minus 1. So let's look at those 2 circumstances. So either they're both 1, in which case the fact that B equals A times M1 tells me, aha, B equals A. Perfect. The other circumstance is that they're both minus 1, but then B equals A times minus 1, i.e. B equals minus A, and B equals minus A, and voila. Okay? So, I hope that kind of makes sense, and in the next lecture I'll actually kind of show you how you'd write it all out in sentences. Okay? So, I will see you in the next lecture.